compliance activities as an integral part of their business. As you said, they are integrating circular economy inside. But this specific case we are bringing forth is one of the key areas of sand disposal in the industry. And it has been 6 years since they have got invested into this. And I'm very glad that as a foundry, they are ready to share all their knowledge, experience, challenges, opportunities, and how they went through. So let's have Mr. Reddy to share how they are looking at the outer loop, the recycling, and how they are able to integrate this into the foundry. So Reddy sir, all yours.
Good afternoon to all. As we seen the speakers, as Manish told that foundry circular economy in foundry is already in place right the day the foundry starts, because most of the areas the materials are being reused in the foundry. But as Miss Swati told that the mainly the foundry uses a lot of natural resources. The sand is being the main natural resource where we have to get from river beds and mining of the sand. So it means we are depleting the natural resource. Maybe some part of time we may not be available also. And also there are a lot of restrictions, regulations to use the natural resource. So I am focusing more on how we make this sand use back into the system, because most of the foundries has to dump the sand into the landfills. So we have to how to make this sand reusable into the system. So it becomes a green sand reclamation has become a really necessity for the foundries. I would like to tell what made Breaks India. So we have how our idea is manifested, what stimulated Breaks India Foundry to strategize the sand reclamation technology, and what are the key decision factors to adopt this technology, and what is the cost benefit analysis of this using this technology, and what are the key sand quality parameters which are used to validate this process and monitor this process. Because after all, whatever we do, it should not be just investment for the sake of investment. We have to reuse and make it happen, and also we have to see that we get returns on the investment also. It is just not like the investment alone. So today's session, I am going to my presentation going to be heavily technical. Hope here I think many people from foundries are there who can really see the terminologies what I'm using here, technical terminologies regarding the sand. If any persons who doesn't have a foundry exposure can ask me questions, I am ready to answer at the end of the session or personally. Yeah, yes. So this is our actually our Breaks India's our mission is zero discharge. So our mission, our vision is that environmental sustainability is preventing the pollution so that natural ecosystem is maintained, and circular economy. All of us that there are 5 or 3 R's. We should not. So we should try to reduce or refuse or recycle the things which we are using inside the foundry. And innovative technologies use the leverage technology which we can able to mitigate this waste of the sand, waste sand disposals. And there are many regulations by government So we should not think just I have to meet, somehow meet the pollution control board or somehow meet the regulations. We should go beyond the regulatory requirements so that it becomes more proactive. All of us today, I think we are comfortable as long as we get the sand, but the day will happen that there will not be any availability of sand. So our foundries cannot operate without sand. They have to close the foundries. It is that very important. And of course, this is the last what I say. We need to have the first the partnership with government because and some business and the communities so that we can engage and make a cluster group like that so that we can also take farming group and go to the government and ask because many foundries cannot invest. It is a co-investment, so they cannot invest and they cannot have the capacity to go to the government agencies so that we can make a cluster and to make a sand foundry, sand disposals to almost at least 50% of it should be stopped using from the natural system. So from now onwards, the session going to be heavily technical. This is how we are a dysemitic sand foundry, where this is a typical how the sand is processed in the plant. We run the plant through a PLC controlled programs. Is a typical modern dysemitic foundry where almost 97% is already recycled. But we had to discard some sand, about 3%. But 3% itself is about a foundry which produces 4,000 tons a month. Almost it will be 10 to 12,000 tons of sand per year needs to be discarded. See, imagine one foundry alone. There are so many foundries. We ourselves have 5 foundries. So it is really a very requirement to make use of this 3% sand which we are disposing. Of course, we already have in the other, for example, reuse of the fines. We are already using the system. So our plant is like that we use back the fines into the system, but discarding sand becomes a necessity. It was necessity for us to discard. So where we have emphasized how to make this sand use back into the system. These are 5 R's which everyone know. So we have already implemented the 4 R's like refuse, reduce, reuse and reform. But the reclamation part, because the sand foundry, when the sand has to be circulated, we have to maintain the level storage hoppers. So to maintain the storage hoppers, we have to take out 3% out. Otherwise sand will overflow, plant cannot run. So this becomes a necessity for us to implement the reclamation. So what are the criteria? The criteria what we selected, there are 3 factors which for implementing the green sand reclamation. One is environment, all of us knows. So do you have to conserve the natural reserves and reduce the CO2 emissions because sand has to be transported one place to another place. It is not available just near our foundry. It has to be transported from many kilometers because it's not available everywhere, every area. We have to transport. There is no way. So CO2 emissions straight away it is going to be reduced, and fuel, reducing the fuel by transportation cost, and industrial waste dumping. Already many foundries are doing the industrial waste dumping. We have to avoid. Somehow now there is no major government is not telling anything. People are dumping the sand, but the day will come where it may be restricted. So we have to see that. And economic factors, because sand, reducing the sand, cost of managing the sand, because cost of management is we have to go to some mines, get the sand processed and bring it back. So how to emphasize the cost of reducing the cost of managing the sand, and nowadays getting the good quality of sand is very difficult. So consistency in the sand quality, and which directly affect the rejections, because foundry is a major rejection in the foundry is the inclusions. Inclusions comes from the sand. So quality of sand is very important. If the quality of sand is not okay, we get rejections. And saving in additives. Apart from sand, we have to use like materials like bentonite and coal dust, which we need to reduce the sand additives. when we start using the reclaimed sand, we can reduce those additives. So naturally, we are going to save money in that. And most important is the mining restrictions. As I already told you, that sand is prepared, washed from the mining. So there are government restrictions also. Recently it happened, I think many of us knows, in Andhra Pradesh. There is almost for 6 months of the government formation, but I don't want to tell about the political this thing. They stopped for 6 months. So 8 months, 8 months it is. So see how we have to run the foundries. The big foundries like that, we can spend money, get from maybe 1,000 kilometers and use it. But what about small scale foundries? It's very difficult. So it is a business loss for us. So when we have reclaimed our own, we can reuse this in the system so we don't depend. And it may be happen that in future government have restrictions on mining to make the sand. And another aspect is technical aspects. See, getting a good quality of sand, what I told is very difficult now because it has to be processed. Sand is not directly digged from the ground and given to us. It has to be processed by them also. There is a process required there. So it straight away cannot be used, dig some land and get the sand and use in the foundry. It's not so. They have to do. So getting the good quality of sand is also a really problem. So that is mainly the AFC distribution and purity of the sand and the grain shape. Because now it's very difficult to explain what is the grain shape, because that's where the grain shape, the sand should be round in size, round in shape. So that gives very good quality surface finish of the product. So this reclamation process, really by default, making the sand more round. So that is an advantage. And how we selected, the process selection, because when we looked at 5 years back, we were thinking how we have to go about this. Then there are several types, because several types of mechanical reclamation, like impinging, then force and impacting available to clean the sand and make it to reuse back into the system like a new sand. And washing also, we can do sand washing also, so that we can use back. And economic factors, it's not that easy to just reclaim and use. We need electrical energy, gas energy, and the investment. So we need electrical energy, the gas, and of course for investment, the payback period. So we have to get returns on investment and cost of operation in the plant. So what we decided, after seeing all the factors, we decided to use a simple mechanical impinging type system, which is very simple and easy to use. And the plenty of gas, we started our reclamation plant in Gujarat. There are plenty of gas available and renewable energy available. And how future, suppose today I am investing maybe 1.5 crores or 2 crores. So considering the future availability of sand and cost of sand, even though the payback period is not going to be 2 years or 3 years, but it is viable for us. Even though investment, returns on investment is high, but it is viable because when we look into the future, it's required. And foundry generates both. Our foundry uses both returns new sand as well as the core makings. We make molding process and core making process, where we need to generating both waste. So since we have both, so we decide to go for a mechanical and thermal plant. So this just I want to tell for our foundry like Breaks India alone. After reclamation, even 50% I use, there will be sustainable impact of 3 crores per annum. When we use the reclaimed sand, I can reduce the additives by 20% in my system, which has a sustainable impact of 3 crores. And for core making, we do thermal reclamation for core, we can have use of that at least 2.5 crores per annum. So here I would like to see how we have selected the process, what type of process we have adopted for a reclamation. There are 3 stages of reclamation. We can do a green sand alone, do mechanical reclamation and make use for molding. There is a thermal treatment where we can use the cores, rejected cores. After thermal treatment, we can use for a core making, like a taking of the new sand. And there is a mechanical thermal plus mechanical system. So we have made this three-stage process where this becomes a flexibility for us, because we generate cores, rejected cores, which we can do thermal treatment and use back for core making, and have a green sand. I can do mechanical reclamation and use back into the molding, or I can use the green sand, do mechanical, thermal and mechanical, and use as a fresh new sand into the core making process. This is how it looks in our plant. So this is, I already explained, this is the sand plant system. From there, the discard sand goes to the discard sand. From there, it goes to the sand reclamation process. There the sand, I already explained, we have used the terminology of S1, S2 and S3, the three type of stages of reclamation. So where the reclaimed S1 sand, S2 sand directly goes back into the sand plant for usage. And for core waste, we can do the reclamation and reclaimed core sand directly used for core making. This is how the schematic diagram. This is how we made the mechanical, thermal and mechanical reclamation. And this is how it looks when it is a sand is very fresh, very green sand looks like this. After stage 1 reclamation, it looks the second one, and the thermal reclamation sand looks like, the color is changed, and the mechanical reclamation is like a new sand. These are the input and output operational technical and operational parameters, where the sand should have a certain quality parameters. So what we targeted, the parameters like sieve distribution, loss of ignition, what we want after the reclamation process, we get almost what is required for us. And operation parameters mainly electrical energy and the gas energy, gas consumption. What we thought in the project stage, the consumption almost it is meeting the expected the operational gas and electrical energy. This is how the plant looks here. And key process parameters results, because the main thing is when we do reclaim the green sand, the sand should have the basic original properties so that it can be used back into the system. So when we see that, when I already explained that S1, S2 and S3 process, when we do reclamation, almost S3 process where we do mechanical, thermal and mechanical is almost looks like the new sand that is containing about 0.15 loss on ignition. It's almost like a new sand. And this is how we use this sand for core making. We tested the core which is used in the foundry, and the core strength properties are meeting the requirement. So the sand, green sand, after the mechanical, thermal and mechanical reclamation can be directly used into the core making, which anybody can imagine. It looks S3 mechanical reclamation. It looks like the original sand. It's not no more a black. So I would like to tell the results. So what from our experience, because we are running the plant for almost 2.5-3 years, and also started in one of our other foundries. It's about, if you see average fresh sand, we are buying at 3,500 rupees. So the reclamation, mechanical reclamation cost about 1,500 rupees for us. Which even 50% I am using that. It will have an impact for us for 3 crores per annum. And 50% of sand, this sand we are using back. So we are purchasing the new sand almost 50% less. And reclaimed core sand we can use 100% to the core making. And we used both sands as explained the green to core and core to core. It means the thermal reclamation of core sand and mechanical and thermal and mechanical reclamation of the green sand can able to give the results of the core, which we can use core directly into our production process. But there are some challenges we face because it was very hard for us to know, because it's not that easy to start and use it. So we face a lot of challenges, and with this reclamation sand. So we started using this sand into our system. So when we started using the system, the mechanical reclaimed sand and S1 sand and thermal reclaimed sand S2 sand. When we started using the S2 sand, we are seeing our sand plant system, our prepared sand properties are not coming all right. There's a property called wet tensile strength, it is not coming all right. So we said what to do. So we invested and we are doing mechanical and thermal. But thermal reclamation is costly, but it looks like a new sand. So probably technically what happens when you do thermal reclamation, the sand which you are using, it has to be coated with the other materials, additives. So it's not fully burning and not giving a desired thing to use in the system to get that. So what we decided that we have a 3-stage process. So what we showed, we use the mechanical reclamation of the sand only used for molding. So this is how we tested in the lab. So we found that why the properties are dropping down. When we tested in the lab, we found that the wet tensile strength property in the sand is coming down. So what we decided that use the mechanical reclaimed sand only for molding and another S2 sand used for a core making. So these are the learnings and overcoming the challenges. See, this plant is already, reclamation plant is located outside the foundry, means not outside, but is away from the foundry. So it is becoming a challenge for us. So what we did, we made the thermal reclamation plant shifted to somewhere only used for core reclamation and mechanical reclamation used for the molding sand. But transporting the sand within the foundry to other regions, cost of transportation, manpower cost is becoming a really more expense for us. So what we decided, why cannot integrate this plant into our mother plant to sand plant system? So what we did, we integrated the reclamation process into our sand plant itself. So where the discarded sand directly goes to the reclamation plant, from there it reclaims, goes back into the used sand, directly can be used into the system. This is how it looks. So the sand after reclamation, taking from the sand plant, after reclamation goes to the sand plant storage hoppers, where I can use both new sand and reclaimed sand to the percentage available, so that there is no manpower required. It will be automatically run and you can use this. And here the reclamation, only 75% is the recovery for us in the reclamation process. So what to do with the 25% of the fines? So what we did, we have made a, we have a patented, we made some patented technology. So we made the bricks using these fines, some other additives. So we made the paver blocks. When you compare to outside the market, this paver block strength is more. But we need to take up this, go forward, make a plant so that we can use these bricks. Outsides can use the bricks as we can use as a part of CSR. We can even some people don't want to use because it's black in color. So we can use it to people because it's having good strengths. And we cannot market from our side. So we have to make the people to use this, at least as a part of CSR, we can. So this is our journey as a part of sustainable strategy. So this sustainable environment, this is zero emissions, zero landfilling, and we have to become 100% water positive and use 100% renewable energy. So we are right now using renewable energy at 80%, and we are about 80% water positive. We have our own water resource which generates in the pond. And care for the people, and we want to be a responsible business, because what are the almost business decisions are made, it should be a sustainably centric business decisions. And as Mrs. Swati told that we had to use this technology in the design stage itself. So now what we are doing, our upcoming foundries, we are integrating this reclamation plant in the project itself. So in the time of initial investment, this becomes a part of the project. Recently we have one more prismatic foundry, this project set up in Gujarat plant, where we introduced the reclamation process in the sand plant design itself. So that's how that's how our journey from beginning 5 years back to now. Thank you.
Thank you very much. So, since we don't have too much time, so you set the tone that it is possible. Okay, now let's invite how we can take this to a larger context, and I'll invite Mr. Bhardwaj and Mr. Sugamji. And if you can have the chairs over here, so we can have a panel discussion here. Sir, can we have the chairs here, please? Ajay, sir, let's please join us. So